from acyl chloride. The first is from acyl chlorides. As you know, acyl chloride is a functional group which is also known as acid halide, or we can call it acid chloride. And in this, how we are going to prepare, it's very important preparation. First, we need to make or prepare dialkyl cadmium, and in order to use this prepare this dialkyl cadmium, we have to take this RMGX, which is Grignard reagent, with cadmium chloride. With cadmium chloride, 2 mole of this, and this you can easily form this CdCl2 and then 2MgXCl. It's very easy to understand that you know that chlorine is a non-metal, so it is electronegative. Delta negative will be here, and this will have positive charge. Now again you can see that magnesium will have positive sign and this will have negative sign. So what you need to do, it's very easy to understand. This negative will go with vitamin CdCl4. So here we will prepare R2CD, dialkyl cadmium. Dialkyl cadmium. So as you can see, this is this negative will go with this positive, and you know CD has +2 charge, and this R will have 1 valency, so it will form CD, R2CD basically. What R2CD, and this will combine with this, so 2MgXCl. This is the X. So after preparing this dialkyl cadmium, we need to react this with acyl chloride. So I'm going to take this acyl chloride as this. This is your acyl chloride, 2 mole of this in order to balance it. And this R2CD. Again, you are going to follow the same mechanism or the, you know that this will have positive, this will have negative. Okay, and you know that this will have negative, this will have positive, because chlorine is more electronegative and this is more less electronegative. So it will attack here, so it will form R dash C double bond O, and this R will come here, and in order to balance it we need to multiply it by 2, and this will combine with this, and you can see 2 into Cl, that means 2 CD, so it will form CdCl2. Is that clear? 2 Cl, so it will form CdCl2. Now in the first step, you can see in the second step you got the CdCl2. Now what you need to do, again you can use with Grignard reagent and form dialkyl cadmium. This is your dialkyl cadmium, and this dialkyl cadmium will be reacting with acyl chloride and forming ketone. So it's very easy to understand. So can you write a sentence about this? How we are going to prepare ketone from acyl chloride? First, we need Grignard reagent and cadmium chloride to form dialkyl cadmium, and then again this dialkyl cadmium will be reacting with acyl chloride or acid chloride to form ketone, and as a byproduct we will get cadmium chloride. Is that clear?
Yes, sir.
Please do let me know when you are done with this.
Done, sir.
Very good. So if I'm going to give you a question on this, can you do this? CH3, CH2, CH2, MgBr reacting with cadmium cadmium chloride will give you A plus B. You are going to take A and reacting with CH3, C double bond O, Cl. Then tell me the main products C and D. D will be basically your same CdCl2, that is understood. So you need to tell me this A, B, and C.
Sir, B is MgBrCl.
B is MgBrC. Very good. A is what? You can take this as 2 moles in order to balance it.
Sir, C will be hexanon.
What about A? A will be your CH3, CH2. Oh, wait a minute, I just did a mistake. It will be CH2, right? So it will be
Yes, sir.
CH3, CH2, CH2 whole twice. CD, right? And after
Yes, sir.
it will be basically CH3, C double bond O, and then CH2, CH2, CH3. So I think there's 3 carbon and there are 2 carbon, 5 carbon only. How can you
Oh,
have
yes, sir. Now I got it.
pentane 2 on or pentane on, right? So this is your first preparation. Now going for the next, which is from nitriles. So from nitriles, nitrile, that is cyanide. You're going to use this cyanide, C triple bond N, and this is your C6H5, and then MgBr reacting with this Grignard reagent in the presence of ether. Then see what we will get. It's very easy to understand. If you have this part, CH3, CH2, C triple bond N in the presence of C6H5, MgBr in the presence of ether. So what will happen? One of the bond will be broken, and here, as you can see, let me show you. This will have negative sign, this will have positive sign, and this will have negative sign, and this will have positive sign. Yes or no? Magnesium is matter, so this bond will be broken and there will be negative charge. So in this way you can say this is your CH3 and this is your CH, and then C, one of the bond is broken and N has negative charge, to which MgBr will migrate, and this will go to this carbon and it will form like C6H5. Is that clear? And after hydrolyzing it reacting with water, you will get C6, sorry, yeah, C6H5 we can write first, or we can write CH3 CH2. C, CH3, and then, oh wait a minute, it forms only, okay, CH3 CH2 and C double bond O and then C6H5. So basically what happened here, this bond will be broken and oxygen will be there, and this all will be byproduct. So please do write it. If you still have any doubt, let me know. Is that clear, Madhya?
Yes, sir.
So let me know when to change the slide. Amen.
Yes, sir.
So we just started this preparation of ketone. You were absent in the last class, right?
Yes, sir.
Now, why it is so?
I think it was because of my exam.
Okay. Let me know when you are done with this. Madhya, are you done with this?
Yes, sir.
Amen.
Yes, sir. Done.
Take a screenshot of this also. We just started from here, preparation of ketone. I'm done.
Yes, sir.
Okay, take a screenshot up to this. This is the main.
Yes, sir. Done.
The third preparation is from either benzene, or we call it benzene, substituted benzene. And this reaction you have already studied in the previous chapter, acylation. The name of the reaction was acylation. So here we are going to do acylation of this benzene. So there is a benzene, and if you are going to react this, either AR stands for arenes, that means benzene, R is for alkyl group, and you can see this is your acyl halide in the presence of anhydride AlCl3. Anhydride AlCl3. Then what will happen? This is your hydrogen part. Okay. So this will be removed. You can see this will have negative charge, this will have positive charge, and this will have positive charge, this will have negative charge. So this hydrogen and this chlorine combine to form as a byproduct HCl, and this positive will be attacked on carbon, this part negative. So as you can see, what will be the formation of product? As you can see, this is your benzene, which is C double bond O, and then R or AR, whatever it is. So what you just need to do is add negative to positive, positive to negative, and you will get the product. So please do write it. And this is your basically Friedel Crafts acylation reaction. Please do let me know when you are done with this.
Done, sir.
Very good. Aman, are you done with this?
Yes, sir.
Okay. Now, as you can see, this was the preparation for ketone. Now we are going to deal with physical properties, and after this, we will deal with chemical reaction, which is very important. So in physical properties, I'm going to talk about this boiling point. And you know, boiling point is directly proportional to molecular weight. If molecular weight is higher, that means van der Waals force of attraction is also very high. And if force of attraction is high, that means boiling point is high. So of comparable mass, if you are going to take alkane, like I'm going to take the example from NCRT, that is butane, which has atomic mass of 58. Then I'm going to take methoxyethane, that is an ether, which has an atomic mass of 60. Then I'm going to take propanol, that is atomic mass 58. And then acetone, that is propanol, that has atomic mass of 58 also. And then propanol, which is alcohol, which has a atomic mass of 60. So these are all these are all basically your comparable masses and different compounds. Now all you need to take care is that this propanol, I'm going to take this as A, B, C, D, and then E. You know, there will be a high hydrogen bonding, more hydrogen bonding in alcohol. That's why its boiling point will be most. After that, acetone, that is D, that means ketone. And after that, propanol is there because it also has hydrogen bonding, but lesser than the alcohol. So then it comes C, and then methoxy B, and then come E. So alkane has the lowest boiling point of comparable mass among these. So take care of it, because I'm going to give a question on this. You will have to deal in the same way. So the question is, write in decreasing order of boiling point. Write in decreasing order of boiling point. So first one is butanol. Second one is butanol. That means alcohol. Third one is ethoxyethane. Fourth one is butane. So please do this and let me know the answer.
Sir, the answer is butanol, ethoxyethane, and then butane.
Very good. Then your answer is correct. So basically, there will be this is A, B, C, and D. So butanol, then A, butanol, and then C, and then D. Got it, Ammon?
So how is ethoxyethane has a higher
Yes, you can see.
boiling point?
If you're going to do the comparison of atomic masses, this will be higher. So that's why van der Waals force of attraction is greater. And you know, C2H5, that means basically this is CH3, CH2, and then O, and again CH2, and then CH3. So you know that this is more electronegative. So there will be delta negative, delta positive, delta negative, delta positive. So there will be force of attraction. So it is greater than LK. Okay.
Okay, sir.
Let me know when you are done with this. Are you done with this?
Yes, sir.
Very good. Now we are going to deal with the next. This is about the physical properties. Now we are going to start chemical properties. Or chemical reaction, you can say. So in this, we are going to deal with a very important reaction. That is basically your nucleophilic addition reaction. Nucleophilic addition reaction. First, I'm going to explain the mechanism, then we will take some examples and deal with it. So, this is your basically carbonyl compound, that is aldehyde or ketone. And you know that this is basically more electronegative. What oxygen is more electronegative, so it will have delta negative and delta positive. And oxygen is powerful electronegativity, so it will take electron from carbon. And here nucleophile is waiting. As you can see, when oxygen took the electron from carbon, there will be deficiency of electron on carbon, so this nucleophile will directly attack on carbon. On carbon. Now you can see this is step one. This is your step one, and this step is basically slow step. Slow step, that means it is a rate determining step. And after forming, you can see nucleophile is here, and I'm gonna show you in 3D. This is your wedge and dashed. This is your A, and this is your B bond. A and B is any group. So this will be O negative, and then again this is your B, and this is your A. And in the next step, you can see it will be reacting with H plus, that means acid. This is your step 2, which is fast. So H plus will directly go to which? Oxygen, because it has negative charge, so it will attract H plus and it will form OH. This is your B and this is your A. So this type of reaction is known as nucleophilic addition reaction. Nucleophile will be attacking on electrophilic center of the reactant and a product is formed, and this reaction is known as nucleophilic addition reaction. And this is your the geometry will be planar because carbon has sp2 hybridization. Please do write. Are you done with this? Amen. Amen, are you done with this?
Yes, sir.
Very good. So there is a question, this carbonyl compound can be aldehyde or ketone. So if there is a nucleophile that wants to attack on either aldehyde or on either ketone, so you can see this is your nucleophile and this is also your nucleophile. Can you tell me on which aldehyde, whether aldehyde or ketone, on which nucleophile can attack easily? That means which one is more reactive, aldehyde or ketones? Nucleophile can attack in both case, aldehyde or ketone. On which this nucleophile can easily attack, or I can ask, out of this aldehyde or ketone, which is more reactive? which can be attacked easily. Do you have any answer? If you don't have any answer, please do let me know.
No, sir, I don't understand.
Okay, see. This on the right hand side, only H is there, and on the right hand side or left hand side, both sides you can see CH3, which is a bulky group as compared to hydrogen. Hydrogen is very small as compared to CH3. Yes or no? Because it has 3
Yes.
hydrogen and 1 carbon, and it has one side CH3. So if nucleophile wants to attack on this, so asteric hindrance, that means crowd in ketone is greater or more as compared to aldehyde. So aldehyde can be attacked easily by this nucleophile. By this nucleophile, aldehyde can be attacked easily by this nucleophile because it has not bulky group. Are you getting my point?
Yes, sir. Okay.
So I'm going to write a point. Write with me. Aldehydes are generally more reactive than ketones in nucleophilic addition reaction due to asteric and electronic reasons. There will be repulsion, more repulsion than aldehyde. Please do let me know when you are done with this. Are
Yes,
you
sir.
done?
Done.
Very. Now we are going to take example of this nucleophilic addition reaction. So some important examples of nucleophilic addition reaction. So the first one is addition of hydrogen cyanide. Addition of hydrogen cyanide either in aldehyde or ketone, because we are studying the chemical reaction of aldehyde or ketone. Hydrogen cyanide, that means HCl. I'm going to write a point and then I will explain the reaction after writing the reaction also. So write with me. Aldehydes and ketones react with hydrogen cyanide. React with hydrogen cyanide. That means HCl to produce or yields or to form cyanohydrates. Cyanohydrates is a compound. You will see how it looks. And this reaction occurs very slowly, or this reaction goes on very slowly in the presence of pure HCl, in the presence of pure HCl. Now, in the presence of pure HCN. And to make this reaction fast, we need to convert this HCN to CN minus. So I'm going to write a point about it. Therefore, it catalyzed by a base and forms cyanide ion. Cyanide ion, that means Cn minus, which is a strong nucleophile. Which is a strong nucleophile. Let me know when you are done with this. So we don't react directly HCN with aldehyde or ketone because it is very slow.
Yes, sir. Done.
So I'm going to show you the reaction. So the reaction is basically, as you can see, this is your HCN. First, we are going to catalyze with the base. It will be converted into Cn minus, cyanide ion, plus H2. Now, this is a strong nucleophile, C double bond O, like this. So this has delta negative and this has delta positive. It will go like this. And as you can see, this is Cn minus. So basically what will happen here? There will be electrophilic center at carbon. So this will directly attack on carbon. Now the bond between carbon and oxygen, double bond, is one of the bond is broken. Now this is O negative and this is your Cn. And this is known as tetrahedral intermediate. Tetrahedral intermediate. And after this, we are going to react with this H plus, and it will be converted into Cn, and this is your OH, and the other bonds are as it is, and this compound is known as cyanohydride. Please do it. Are you done with this?
Yes, sir.
Okay. Now the next question, see. The next is basically addition of sodium hydrogen sulfide. Sodium hydrogen sulfide. So basically we need to add sodium hydrogen sulfide to this carbonyl compound. Sodium hydrogen sulfide has a formula NaHSO4, NHSO3. So as you can see, this will have negative, this will have positive, this will have positive, this will have negative. So what you need to do, just add the negative to positive, positive to negative. And it's very easy. So this bond will be broken and then CO and then this and this ONA. Now, how we are going to write this? Be focused here. This Na plus comes to an O, and one of the bond, that is, this will be your negative part, that will go to this. So HSO3, I'm going to write it as OSO2H. Can I write this? I just added this HSO3 minus
Yes, sir.
to this. So I just write a OSO2H, and after this, proton transfer will take place. Proton transfer. So by proton transfer, that means Na will go to this and hydrogen will come to this. So this will be your OSO2Na, and here it will be OH. And this is known as bisulfite addition compound. Which is crystalline solid. Please do write it. Let me know when you are done with this.
Yes, sir, I'm done.
Okay. I'm going to give you some question. Please do it and send it to me. Why you don't send the
Sir, I
sorry.
do, sir.
Okay. That means you are not present in the test, right?
No, sir. Last class I was in there. Sir, tomorrow I have my chemistry pre-board exam, sir. So which chapter should I focus on more? Which area.
You should cover the organic as well as physical chemistry. Did you study the inorganic part? Yes or no?
Which chapter, sir?
P block.
No, sir. I have to study that as well.
Okay, just look at the P block.
Okay, sir. Sir, and is it possible for me to take extra chemistry classes because I need the help?
Or what type of help, like solving assignment or?
Sir, just like a revision of all the chapters from starting.
We will do revision, but after completing the syllabus, you want
Okay,
to
sir.
do the yeah, you want to do
So
revision before
yes.
that.
Yes, sir. Because my my pre-board exams are going on. So exactly when will these syllabus be completed, sir?
That this is in this month, most probably.
Okay, sir. So,
Please do write it.
okay, sir.
Let me know when you are done with the first question.
Okay, sir.
Are you done with the first question?
No, sir. Almost.
Are you done with the first question?
Yes, sir.
No. Please do let me know when you are done with these questions and make a PDF and send it to WhatsApp. Are you done with the question?
Yes, sir. I've copied all the questions.
So please do it and send it to PDF form. Okay.
Okay, sir, I will.
And after solving it, you may leave.
Okay, sir.
Aman,
Yes, sir.
have you completed the test?
Almost, sir. I'm doing the last three questions.
Okay, please do send it to WhatsApp in PDF form.
Okay, sir, I will. Okay, thank you,
Thank
sir.
you.